So this is video walkthroughs of the examples that are in the textbook. I know some of you like to read rather than, watch rather than read, so thought I'd do this recording. And maybe I can add a little bit more to what the book is showing. So for this first one, it's really just using the unit circle. I'm looking for when is the sine equal to 1/2. Now you got to remember back from our earlier work, positive angles of rotation go counterclockwise, and you got to remember the sine is the same thing as the y. And so here I see a place where the y equals 1/2. Well, that's 30 degrees, or pi over 6. And the reason, remember, the reason why the y is 1/2 is on the unit circle, the opposite side and the adjacent side are if this is 30 degrees, this is half the hypotenuse. So hypotenuse is 1, that's going to be a half, that's going to be half root 3, which is what we're seeing. And so where else is the sine equal to 1/2? Well, it's where the reference angle is also 1/2. 30 degrees, or pi over 6, which is way over here at 5 pi over 6. Notice the sine's 1/2. Now if we look at the other places where the reference angle is 30 degrees, or pi over 6, down below the x-axis we see the sine is negative 1/2. And over here the sine's also negative 1/2. So those two are not solutions to this equation because we aren't looking for when the sine's equal to negative 1/2, but when it's equal to positive 1/2. So we've got two solutions here in there, but they're looking for all possible values. So what we got to do is we got to think about how can I get back to this point? What other angle of rotation is coterminal to this angle of rotation? Well, we have to go all the way around again in order to get back there. So the way we write that mathematically is say, hey, pi over 6 is a solution, and then we're going to add 2 pi radians. Or if we think about it in degrees, usually we work in radians, would it be 30 degrees plus 360 degrees? And in order to get back there again, we'd have to go all the way around again and add another 2 pi or another 360. So the way we show that is we write a k next to it to show that, hey, I'm going to multiply 3 times around to get my solutions. Now the same thing can be said about 5 pi over 6. I'm going to add 2 pi k. Now how does that relate to the graph? Oh, and then of course I could do 30 degrees or I could do 150 degrees plus 360 k degrees k. Better answer here. Better to use radians in trig. So how does that relate to the graph? We spent all that time graphing sine and cosine. So looking at the graph of sine x and y equals 1/2 x, there's the 5 pi over, or the pi over 6. Then they show in the next solution is 13 pi over 6. Well, you think about 5 pi over 6 plus 2 pi, or 12 pi over 6. That's where they're getting the 13, because 1 pi plus 12 pi is 13 pi over 6. And if we subtract it, pi over 6 minus 12 pi over 6 is negative 11 pi over 6. So you can kind of see where those solutions are coming from. Same thing with the 5 pi over 6. You take 5 pi over 6 and add 12 pi over 6. That gets you to 17, because 5 plus 12 is 17. And then we could subtract it and get to negative 7 pi over 6. So that's how we're going to be writing out. When they ask you for all solutions, that's what you got to do. So in this one, we're looking for when is the tangent equal to 1. Well, I'm hoping you remember that tangent is the same thing as sine over cosine, which is the same thing as y over x. So when is the y, and the only way you can get that to be 1 is if y and x is the same. So that happens there at 45 degrees, or pi over 4. Remember, that's an isosceles triangle, isosceles right triangle. And the same thing happens over here, and the same thing happens down here, and the same thing happens here. However, in this quadrant, only the y is positive, the x is negative. So if we do positive divided by negative, we're going to get a negative value. So here the tangent is -1, not a solution. Same thing here. Negative divided by a positive will be a negative, so that's not a solution. Here's my only other solution right here. And that's at 5 pi over 4. So I've got pi over 4. I've got 5 pi over 4. Where's the next place where this is going to be a positive one? Well, I have to come all the way back to pi over 4. So what am I adding each time to get to each of these values? Well, here's a graph of the tangent function, and I also graphed line y equals 1. And what we're seeing is our solutions. And what I want you to recall is, what's the period of the tangent graph? How often do I have to go to get it to repeat? In other words, how wide are each of these intervals? And I'm hoping you're realizing that they're pi wide, half the unit circle. So the way you write the solution for this kind of function, tangent and cotangent, we're just going to write pi k, not 2 pi k. Okay, that'll take care of all solutions. Okay, so now we're looking at example 3, and it talks about the depth of water at a dock rising and falling according to the tide. And they give us the equation, so it's modeled by it, and we're asking between what times will the depth be 9 feet or greater, they aren't saying. So I graphed this earlier, and what I'm seeing is between 2 a.m. And 10 a.m. is when the water is going to be above 9 feet deep. So how do we do that algebraically? Well, what we're going to do, this looks fairly complicated. That pi over 12 is messing us up. And I hope what you're realizing is, oh, this has a period other than 2 pi. And I kind of, there's a reason why I had it draw the line x equals 24. Because if this is in a day, tide has 12-hour cycle, or 12-hour, or even, you know, two high tides and 2 low tides every 24 hours. That's why I cut it off here at 24. And that's going to be the period. And if you actually think about it, let's talk about the graph here. I know that it has a midline of y equals 7. I can see that there. And it has an amplitude of 4. So it went up 4, it's going down 4. The period, if we talk about that, if we take 2 pi and divide it by the b number, well, the b is pi over 12. So 2 pi over 1 times 12 over pi. Remember, we take the reciprocal and multiply. That's where I'm getting the 24, so that checks. And I guess so then we can see this is the only 2 places. So again, let's talk about how to solve this kind of equation. Well, what we're going to do is temporarily forget about the pi over 12. Okay, I'm going to do some kind of little u substitution here. I'm going to say that I'm just talking about the sine of some u function, or u variable, plus 7. I want to know, when is that greater than or equal to 9? I guess I could say equal to 9. So I'm going to solve this for the sine. So sine u equals, I'm going to subtract 7, which is 2, then divide by 4. 2 over 4 is 1/2. We've seen this already today in this video. So I'm asking myself, when is the sine, what values does the sine have where it's pi over 1/2, I mean? Well, I hope you remember that from before it was pi over 6 and 5 pi over 6. You can look at the unit circle and confirm that. And then remember how we said to get all the way back around, we had to add 2 pi k? So what we can think about is remember how we did that u substitution? I'm going to have to write it over here. I said that u was equal to the pi over 12. T equals pi over 12 t. Well, we're going to divide both sides by pi over 12. So this is going to be, I'm going to multiply, if I'm dividing by pi over 12, I'm going to multiply by 12 over pi. This gets multiplied by 12 over pi. Same thing here. 12 over pi times, I'll write it over here, 12 over pi. The pi's cancel out, the 6 cancels, that's 2. Pi's cancel, 6 cancels, that's 2. So at 2 a.m. plus, well, let's see, divide that, and 12 times 2 is 24. And that's going to be 2 times 5 is 10. And again, plus 24K. So we can see that at 2 a.m. and then again at 10 a.m., this graph will, or the water will be that deep. So between 10 and 2 and 10, if we think about how the sine graph works here, we know that it's in between those 2 hours. I can go back and take a look at my graph. Yeah, 2 and 10. Good. So that confirms it. Okay. So why don't you try to do this? I mean, graphically, if you must. If you're going to do calculus, you're going to want to be able to do this algebraically. So why don't you stop the video, try this, and come back and look at the answer. Or you can just look at the answer in the book, too, rather than watching the video. So what I'm going to do is I'm going to pretend the 5t is not there for a minute. I'm going to call it u. Then I'm going to isolate the sign. So add 1 divided by 4 is 1/2. Again, I get pi over 6. And I've got 5 pi over 6. And plus 2 pi k. Plus 2 pi k. And that's going to be equal to 5t. So to solve for t, I'm just going to divide by 5. So pi over 30 plus 2 pi over 5. Okay, and this is going to be t equals, well, let's see, 5 pi divided by 5 times 6. The 5's cancel. So I'm left with pi over 6 plus 2 pi over 5. Okay, this tells me the period of this graph, and if you think about it, 2 pi divided by 5 is the period. So it's going around very quickly if you think about the unit circle, jumping right around. That's why we have so many solutions. Now this equation is not a nice equation. 0.6. I don't know exactly when the sine is equal to. Sine is equal to 0.8. So I grabbed my calculator, made sure it was in radian mode, and I did the arc sine, second sine of 0.8, and I got that decimal. Notice that's the same that's on the graph. And that will be the first solution, one solution. So I don't really even need the graph. But then, if I want to find all solutions, that's what the next example in the book asks. How do I know that it's equal to 7 pi, 7.21 is the next solution? Or the one before that is negative 5 pi. Well, what do you know about the period of the sine graph? Well, I hope you realize that that's just 2 pi. So in 2 pi in decimal form, I don't know why I wrote 0.8. I should be writing 0.97, 0.927. Let me erase this and start over again here. Don't know what I'm doing here this morning. So it's 0.9273 plus 2 pi, 6.28. Okay, so that's how it would show all solutions. You could write 2 pi. That wouldn't be wrong to do that. But if you add those, notice that's what you're getting. And if you subtract those, that's what you're getting. Okay, so fairly easy. So notice here that they're specifying they want this in degree measure, 0 to 360. So we're going to ask ourselves, when is the so we're going to do the arc sine. What's the arc sine in negative 8/9? And that's certainly a calculator question. So let's see, second sine of negative 8 divided by 9. Let me get a picture of that. So notice that that is give me, and I put my calculator back in degree mode, and it gave me a negative answer. But they're expecting me to come up with an answer between 0 and 360. Why did the calculator give me this negative answer? What I'm hoping you remember is that the range for arc sine is from negative 90 degrees to positive 90 degrees. So what we need to do is think about how to convert that. Well, if it's a negative angular rotation, negative 62.7 is that's the reference angle. So the only other place that it could be negative, I don't know why I just drew that angle in the first quadrant. The only other place that the sine can be equal to negative 8/9 will be over here, because that's where the sine's negative. That's why we were doing those problems earlier here. Why find two angles or find another angle is equal to the sine of an angle. I don't remember doing that. So that's the other solution. Well, if this is also 62.7 degrees, we're going to add 180 degrees to that. So what's 180 plus 62.7? How many decimal places do we want? 3, 4. So that would be the solution. That would in fact be one solution to this solution to this equation, and the other one is going to be this one here. Let me change ink. Would be this one here, and so that's just going to be another 62.7 degree angle. So 360 minus the 62.734 would be my other solution. And those are the only two that's on that range, 0 to 360. Okay, for this one, so we know we're going to do an arctan. Let's think about what we're going to do, though, once we get that calculator answer. Well, I know the tangent's positive here in quadrant 1. I know the tangent's positive down here in quadrant 3. So I'm going to do my arctan answer, and that should give me this positive angle. And then what I got to remember to do is I'm just going to add 180 degrees, or I'm going to add pi radians to it to get this other angular rotation. Okay, and then those are going to be the only two answers on 0 to 2 pi. So that's what the calculator told me. So so this angle here, 1.249 radians. And then to get the other one, I'm going to add pi to that. So on my calculator, I'm just going to add pi. And notice that's the other angular rotation down here in quadrant 3. That's the 4.39 angle right there. And that's the only two on 0 to 2 pi, because we'll be over 2 pi if we come around again. So why don't you try this one, and we'll and stop the video, go try it, and then come on back. So we know that we're going to be in, because the tangent's positive, I know I'm going to be up here in quadrant 1, and that's the first answer, about 35 degrees. Then the second answer is going to be down here in quadrant 3, and all I did was add 180 degrees, and I got 214. That easy. So what do you think? How do we solve this? Well, we need to isolate the cosine, right? So cosine t, I'm going to subtract 4, divide by 3. So that's going to be equal to negative 2 over 3. Now what you got to remember about the arc cosine is the arc cosine has a range between 0 and pi. So when we get this, cosine's negative, it's probably going to give us this angular rotation right here. And then that'll require that we get the reference angle, because we know cosine's cosine's equal to a negative value over here too, so we'll have to use that reference angle to find this other angle here we're talking about. So let's do the arc cosine of negative 2/3. So that gave me that angle right there corresponds to this angle here. Remember, because that's in the range for arc cosine. So now I've got to find the reference angle. How do I do that? Well, I'm hoping you said, oh, you have to subtract this angle away from pi in order to get that. So, I mean, I didn't mention you did put this in your calculator back in radian mode, right? Because they're telling us to work in radians. So I subtracted the angle away from pi, and that gave me the reference angle, and that represents this angle here. And now to get this other angular rotation, I had to add that to pi. I had to, because my reference triangle is now down here in quadrant 3, so pi plus that reference angle will be that full angular rotation, and that's what I did there. So those are the answers on that range. Over here, cosine's positive, so I know I'm not working with that. So for this one, and because this got cut off, so I'll get a new copy of that. We're going to solve this equation. Well, and the other thing I'm wondering about is, why did they say from 0 to 4 pi over 3? Well, if you think about, and they also notice they're saying 2 cycles. What's the period of this cosine equation or graph? If I take 2 pi, which is the normal cosine period, I'm going to divide that by the b number, which is 2 pi over 3, that's the length of one period. And so if it's 4 pi over 3, they have me go out 2 periods, and then notice they want 2 cycles. So I know I'm going to have to go around the circle twice. So let's momentarily ignore the 3t, and I'm just going to do the arc cosine of 0.2. So I did that on my calculator, and I know that is equal to 3t, because that's the inside. So then I'm going to divide that by 3. And that's where I'm getting this number on that graph. Well, I think I am at least. Yeah. So then we could ask ourselves, where else is the cosine equal to positive 0.2? Well, I know that cosine's positive here in quadrant 1. I also know that cosine is positive down here in quadrant 4. Okay. So we've got to take that reference angle, which we just calculated, that 0.4, that 0.4565, and we're going to subtract. That's how big that angle is also, 0.4565. And then what do we take it away from? Well, normally we'd subtract that from 2 pi, except for this one, what's the period of this graph? So in order to find that other angle, we're going to go 2 pi divided by 3. Whatever that is a decimal. And we're going to subtract that reference angle. Be nice if I could write it correctly. 0.4565. And that would be that blue angle that I just drew in there. So that's that second angle right there. Now, in order to get back to these, we'd ask us what other angles are coterminal to this. Well, I would have to add 1 rotation to that. That's 1 rotation. So I'm going to have to add 2 pi divided by 3 to the 0.456 to get the next angle, and then I'd have to add the same number to this angle, and that would be the fourth solution in that range. Okay, and I'll let you do that on your calculator. Okay, so now they're asking us to do all solutions, and where I'm pretty sure we're doing radians. So we're gonna ignore the pi t for a minute, and I'm just gonna solve this for sine. So sine of, I'll write the pi t, but I'm not going to worry about it, equals negative 2 over 3. Then I'm going to do the arc sine of that. So I did the arc sine of that. I got the and negative 0.7297, and then I divided that by pi, and that got me t equals that. Now you got to remember though, I'm down here in quadrant 4 if the sign's negative, and that tells me this angle is negative 0.232. And if we're looking for all solutions, well, let's see. To get back to this angle, we'll have to add one rotation. If I'm looking at this graph or looking at this equation, I know that 2 pi divided by pi tells me the period is 2. So what I'm going to have to do is add plus 2 pi k, or I'm sorry, plus 2k. That'll list all the solutions that are coterminal to that one. Now there's another place where the sign is negative. That's going to be over here in quadrant 3. That reference angle is still the same. It's still that negative, that positive, it's positive here, 2.32. And I've got to get this plus that little bit to get that angle. Well, if the period for this graph is 2, half of it, which puts it here, is 1. So this whole angle here works out to be 1 plus 0.2323 if you want. So I've got 1.2323. In order to get back there, I have to do a full rotation. Full rotation is 2, and then k will give me the rest of them. Okay, so I hope that helps. Tough question, because we're dealing with not nice answers. We're dealing with a different kind of period, so when we're finding the rotations, we have to keep all that in mind. So this is the last slide that I have here. Hopefully you can try it and stop the video, try it, come back and take a look and listen to what I had to do. So I'm going to ignore the pi over 2. I'm going to solve this for sine. So I'm going to say sine of u equals negative 3 over 5. I'm going to do the arc sine of that. So I did the arc sine of negative 0.6, and then to solve for t, I multiplied by the reciprocal of 2 over pi. Notice I went times 2 divided by pi. So that's that angle, and that's down here in quadrant 4 again, because that's where sine's negative. We also know it's negative over here in quadrant 3, but let's worry about that. Well, let's do that right now. So we know this reference angle right here is 0.4097. I didn't write 0.4097. This reference angle is 0.4097. And I'm not worrying about the positives, but the negatives, because I know I took care of that by placing them in these quadrants. And then we got to figure out the angle between 0 and 2 pi. Well, the period for this graph is going to be 2 pi divided by pi over 2. So 2 pi over 1 times 2 over pi is going to be a period of 4. So half the period is 2. So the first answer is going to be 2.4097. And then here I'm going to do 4 minus 0.4097. And if you bear with me a minute, I'll do that on the calculator. So 0.35903 I got. 3.5903. 5903? Oh, yes. So now we're going to see, they told me I have to find all solutions between 0 and 2 pi, or 6.28. So since I know the period of this graph is 4, if I go around one more time to get that next coterminal angle, if I add 4 to that, I'm already over 6.28. So I'm done. These are going to be the only two solutions on that interval. It's some angles, some equations it's a little different. So that's what you got to check, and you're going to see some of this on your work here, and on quizzes what I ask you. So I hope this helps you solve these kind of equations. And next time we look at trig equations, we're going to have to throw some identities into the mix also. So get some practice with this out of the book and out at My Open Math.